Josh McDaniel. I'm with the Wildland Fire Lessons Learned Center, and I'll be moderating the webinar today and introducing the speaker. But first, I want to make a few quick announcements. First off, I want to note that this is a webinar series, and it's sponsored by three different organizations: the International Association of Wildland Fire, Wildland Fire Lessons Learned Center, and the Joint Fire Science Program. And it's a regular webinar series, and it's been going on for a couple of years now. We usually have one or two a month. There are two more webinars scheduled in the series, and they are part of a extreme fire behavior series that we've been doing for the last couple months. And the next two are April 30th. Scott Goodrick and Jason Forthofer will be speaking on vortices and wildland fire. And then on May 7th, Marty Alexander and Miguel Cruz will be speaking on crown fire behavior in conifer forests. So if you're interested in signing up for those webinars, you can go to the Advances in Fire Practice page, and you get there through the Wildland Fire Lessons Learned Center's website. You can click on that link right there at the top where it says AFP, and that'll take you here, which is Advanced Fire Practice, and there is the registration links for the different upcoming webinars. That's also where we post the recordings for the webinar. So this webinar is being recorded, and after the webinar is over, we'll upload that recording to the Lessons Learned Center's YouTube channel, and the link will be available right here on Advances in Fire Practice. Okay, so couple little logistics things. Like I mentioned, the webinar is being recorded, so you can get that after the webinar. There's always questions about that pop up. And if you would like to ask questions during the webinar, you can type them into the questions box down below in your control panel, and the presenter will respond to those at the end of the presentation. Okay, so now I'd like to introduce the speaker. Matt Busse is a research soil scientist with the Forest Service Pacific Southwest Research Station in Davis, California. He's the team leader for the Water, Air, and Soil program at the research station, and also moonlights as a visiting scholar at UC Davis, where he teaches the undergraduate course Forests and Society. Matt received his doctorate in soil microbiology from Oregon State University about 2,000 years ago, and those are his words, not mine, and has worked for the Forest Service for the past 26 years as a research scientist. He's published on a variety of topics, including long-term soil productivity and the resilience of forest soils to harvesting, fire, vegetation control, and a changing climate. And with that, I will hand it off to Matt.
Great, thank you, Josh. Well, it's wonderful to be here. I appreciate there's a really nice turnout, which makes me feel really good, and I think it makes most soil scientists feel really good. Soils, as you know, are part of the puzzle, and we look at the whole puzzle, and so having such a good turnout is something that we really take as a real benefit here. So what I'm going to do, actually, before I get going, I want to thank all of you for being here. I also want to thank Josh for all this background work, and he's kind of the backstage manager. And also, please, a big thank you to the Joint Fire Science Program. They encouraged this presentation. They gave the opportunity for it. And also, as you'll see, this presentation is based on a synthesis report that was funded by JFSP. So thank you to them. Okay. Let us go here. Josh, I need to get rid of what's on the right side of my screen. Is that showing up on your screen?
No, you're okay. That's invisible.
Okay, good. Thank you. So we're going to talk about dirt. I use dirt synonymously with soil. Soil, of course, is the technical term. It doesn't matter what you use. It's the communication that matters. It's the caring for the land and the integrity of the soil that we're talking about. So dirt kind of pulls people in because we can relate to that term quite easily. I'd like to recognize my co-authors, Emily Mogadas and Ken Hubbard. They're definitely a couple of really talented soil scientists, the brains of the bunch, if you will. And at least for the next 30, 40 minutes, I'm the talking head, and Emily and Ken are not on the webinar. Okay, let's jump right to it. Objectives. I will introduce to you this publication that we put out. It came out last summer. At the end of the webinar, I'll have URL address for you to link into this and get a copy of this. I also have some hard copies, and I'll give all that information to you. Really what we're talking about, though, is I want all of us right now to challenge our current thinking about soils. Okay, we all have this inherent knowledge of dirt. Okay, we grew up with it. We ate it. We played with it. Right? It got on our pants, got on our fingernails. We work with it. We're out in the woods. We deal with it. We talk to people. All these things. And we've developed these concepts. And all I'm asking that we do in the next 30 to 40 minutes is to challenge those concepts. As I go through this talk, please write down your comments and your questions, because I think I'm going to play the role of devil's advocate, and you will have a chance to go, hey, wait a minute, we're seeing something different here. So we'll take this all as a positive view of soils. Okay, whoop-de-doo, this is the International Year of Soils, as defined and put forward by the United Nations. So soils are in the forefront this year, and that's a wonderful thing, because we have these nice sound bites by Tom Tidwell, Jane Goodall, that really speak to how essential soil is. Okay, and my way of thinking, that's nice rhetoric. But still, when you look at soil, all right, what do you see? It's brown. It sits there. It's not like a plant. It doesn't grow. It doesn't talk to us. So there's this discrepancy between the rhetoric of how important it is and what we actually can and think about soil. So I found this on the White House blog just this month, and the point I want to make is here, it takes over 1,000 years to create soil, and we know this. It's a long process, and we can destroy it or deplete it in just a few short years. True, but it's more true with what happened in ancient history, and it's more true with some real rare events these days, and I'll mention one of those in a little bit. But if we're talking about fuel reduction practices, we're not in the same ballpark, right? We're not worried about this. So it's a rhetoric. And what I want you to think about, what do you need to know for fuel reduction practices and soils? What do we need to know beyond the rhetoric? What we need to know is that soil is, unfortunately, outrageously complex. I dare you to find a more complex system on this planet. It's also very malleable. So what you do in your fuel reduction practices does matter. And I will emphasize with this that the key to everything, and I'll come back to this, is local expertise. Seek out your local expertise or help develop your local expertise. That's the key. We know soil is a biological system. So with fire or with mechanical treatments, we can't alter the biology of the soil. There's a concern there. It's also a system that's shifting, and its fertility can shift in any soil, particularly with fire. And soil is a niche. It's a home. And with your thinning practices or masticating, we can alter the physical environment. So these are things that we need to know about and to think about. And now I'm going to give you the take-home message of the webinar. So I'm going to let you know there's some caveats to this to try to keep you on board on the webinar. The take-home message with fuel reduction practices is this, and I think a lot of you know this quite well. Soil is often resilient or tolerant. And when it comes to fuel reduction practices, I think it's fair to say soil is usually resilient or tolerant. There are examples, of course, where this isn't true, and I'll try to hit on some of those. And the main caveat I want to get at here is what I'm talking about is a single event, a fire or a thinning. What we have the least knowledge on and what we need to improve is what happens with multiple entries. What are the cumulative effects of restoring our landscape on soil? We have situations like that soil has been a big part of a disturbance, like what the tragic episode a year ago in Washington. Okay, well, let me move forward now into the fuel reduction practices publication. It actually came out this last summer. not in 2013 as it shows here. What we did, I think it was a nice way to approach this. We sent out a survey to land managers, not just soil scientists, but to everyone that we could think of, to ask what were the issues that were facing all of you regarding the soils. And we collated all these responses and lumped things into categories. And we've come up in this publication with 12 topics. So the 12 bullet statements are the heart of this publication, where we talk about the ecological effects, which essentially is a literature review, and then we offer some management considerations. Now, if you try to read this publication from front cover to back cover, you are going to die. So please don't do that. But it's meant to be as a resource. If you have a question on pile burning or on soil heating, this is where you go to. And what I recommend you do is you go to the first page of each chapter where we have a summary. For example, here's the summary of soil heating, where we list kind of the literature review findings and what you may want to consider about that, management considerations. For example, with soil heating, soil moisture is a critical factor. That's been shown time and time again in literature. So what you might want to do is burn when the soils are moist to limit soil heating. So this is the approach you can take with our publication. All right, here's how we're gonna do this. I've selected a few of the topics in this report, and we'll ask ourselves, where in this gradient between reality and myth are these soil concepts? And we'll start out with prescribed fire topics. Okay, does prescribed fire increase hydrophobicity, the repellency of soils to water infiltration and erosion, if you will? Does it lead to sterilization of the soil, or a flush of nutrients, or excessive damage? Now, when I bring this up, most people's response to this, and it's a correct response, is it depends. And it depends, as you know, on the situation. It depends on the type of fire, the amount of fuel, the arrangement of fuel, the size of the fuel, the type of soil, you know, all kinds of factors, right? But when I try to nail this down when I talk to folks, okay, what do you think? What do you really think? Well, you know, increased hydrophobicity, yeah, I think that's a problem. Not totally sure, though. Soil sterilization, you know, perhaps with wildfire. That's where I think about it. A flush of nutrients, of course. We all know there's a flush of nutrients. You know, that's been shown, and so that's not even a question. That's a reality. Pile burning, boy, I don't really know. So let's tackle these. And what I'll do, I think the best way to tackle these is to recognize that the real pressure here in answering these questions is to understand how hot does soil get when you burn. So let's talk about that. How hot does soil get? So here's a situation where there's a lot of fuel, masticated fuels. They've lit it, and they actually brought this down to bare soil. How hot do soils get? We worry about this because it's not just an academic question like, ooh, well, that's really hot. We worry about it because of what happens to the system. And we have these occurrences at certain temperatures, like root mortality, microorganism death. Hydrophobicity increases around 200 degrees, so we know these things. Soil fertility changes, both good and bad. And then above 500 degrees centigrade, all hell breaks loose, both figuratively and I believe literally. Okay, now one way that I look at this are the temperatures at 300 degrees and less, which are the yellows and the greens. These are the responses where you'll see short-term effects, where the system will recover quite easily. Okay, when you get above 500 degrees centigrade, that's a long-term effect. So we're seeing changes in soil mineralogy, soil structure that are going to take quite a while to recover from. The area in between 300 to 500 degrees centigrade is kind of the no man's land where we don't have a super good handle on that. Okay, so think about those concepts, if you will, and I'm going to run through a few examples. And this is what people are doing nowadays. It's quite simple to get soil heating values. You insert these thermocouples at different depths in the soil. You don't let OSHA know that you're working in these kind of conditions, and off you go. And so here are some examples. And what I call super hot, if you're burning a pile and it's a wood pile. Now here is the heat profile in the soil, time on the x-axis, maximum temperature on the y. Different lines are the different depths in the soil. Okay, so notice the blue is right on the surface. The red is already down to 2 inches, if you will. We're already near that critical zone, and not only is the maximum temperature high, but the duration is outrageous. So wood piles, so about a 24-hour period where we are near the critical zone. Wood piles, super hot. Now let's move down the scale. Slash piles, like this pile here. This is actually this is the heat pulse for this specific pile. And what we have is what I call sort of hot. It's more in that yellowish green zone where once you get into the soil profile, this red line, you're below 300 degrees C. You go down to 4 inches, 10 centimeters, the green line, and you're down to 100 degrees centigrade. Okay, hot, but not that hot. Here's the main principle of soils to remember, and that is that soil is not a good conductor of heat. So with each step down in the soil profile, we have quite a dramatic drop in the soil heat. Okay, that's a good thing. That's what we like to see. Masticated fuels have been a big topic, used quite a bit, and in the earlier days, 15 years ago, there was concern about if we burn these, will we create a lot of root mortality, and on and on and on. We've looked at a lot of masticated fuel beds and burned a lot, and this is the worst case scenario, this graph here, where we're, even still in the worst case scenario, we're not seeing soil temperatures getting that hot. It's not like a wood pile, okay? Good news there. Finally, underburning. This being low to moderate severity burning, and I say not so hot. In fact, I say don't even worry about it. The black line is right on the soil surface, and then these 2 lines below are 1 and 2 inches in the soil profile. A little bit of heat registered, but not much. So that is a look at the types of temperatures we're getting. And as you know very well, that the temperatures are a function of the type of fuels, the size of the fuel classes, the amount of the fuels, the arrangement of the fuels. Was the fire smoldering? Did it move through fast? So these are kind of standard concepts. There's a lot of soil characteristics that dictate how heat transfers in the soil, and they're a little on the esoteric side, so I won't get into the details, except to reiterate that soil is not a good conductor of heat. And as you know, except in wood piles where we've piled up a lot of dirt in the piles, most heat goes up. That's a real positive thing. I mentioned this before. If you're in a situation where you want to limit your heat in the soil, your soil scientist says, that's a good idea to do. Burn when the soil or the forest floor is moist. There's a big reduction in the heat pulse with moist soil compared to dry soil. Okay, let's get down to this now. Everybody who believes that burning can sterilize the soil, please raise your hand. Okay. The one person here in my office says yes, it can. So I'm assuming 50-50 here. Think about the temperatures we just went through. It takes to completely sterilize the soil without our autoclave, it takes about 800 to 900 degrees Celsius. So it's not going to happen. It does not happen. You do not officially sterilize the soil, even though it looks like it in this picture here. Soil organisms are survivors. They're knocked back quite a bit. And as you can see in this graph, as the temperatures go near 100 degrees, there's quite a drop-off in microbial biomass, or the amount of organisms in the soil. But all the way out to 500 degrees centigrade, they're still survivors. Soil is not sterilized. It doesn't mean it's in good shape, but it is not sterilized. And what it means to you in this whole concept of soil heating is these are the take-home messages. If you're doing low to moderate severity burning, just fine, no problem. And we propose you take it a step further if you want to, because this whole concept is to promote both fuel reduction, right, in this restoration concept, and soil health. So it's the meeting of both concepts. And one way to do that is simply to encourage, go ahead and burn more. Burn it in a mixed severity pattern where you have uneven forest floor consumption. So we have, good and bad, if you will, but overall a totally acceptable situation of uneven forest floor consumption. Okay. Let's move on to the next, and I don't need to see a show of hands on this. Does fire lead to increased soil hydrophobicity, or the repellency of water, the inability of water to penetrate into the soil, and thus if you're on a hill slope and you get a storm coming through, you end up with what you see on the right side, this erosion, fairly high erosion rate. So soils are amazing. They have a lot of different organic compounds. Many of them are hydrophobic, waxes, lipids, if you will. And what we know is that this is a natural condition. Not all soils are hydrophobic, of course, but many are. It's natural whether you burn or you don't burn. The compounds are derived from plants, either live plants or decomposing litter or roots. Also, some are from fungi, and these compounds then can coat soil particles. That's how we get hydrophobicity. Fire releases these compounds, and one of the effects at a certain temperature range is we get an increase of coating of the soil particles. So we can see more hydrophobicity with burning. Does that mean you should be concerned? That's a hard one for me to answer, but here's the way I look at it. There's a lot of variability across a landscape or a hill slope in hydrophobicity. It's not a blanketed system. And this is a nice example from Ken Hubbard's work in a chaparral. This panel on the left, this is pre-fire, and you'll see the green is non-hydrophobic. The yellow going into orange is where we had high hydrophobicity. So on a very small scale, these are meters on the two axes, there's a lot of spatial variability in this hydrophobicity, which is a good thing. So when a storm comes, it's not just going to be one big sheet of sediment moving off the hill slope. Fire, the middle panel here, 7 days after the panel, yeah, there's a lot more hydrophobicity. Okay, it's not complete, but it's there. The neat thing then is hydrophobicity after fire is fairly short term. And here he came in about 2.5 months later, and he looked at the pattern of hydrophobicity, and now again we have that nice mosaic. So that's something that we can use to our advantage, and recognizing that with water repellency it tends to be a short-term issue. Tends to be. Does fire lead to increased soil hydrophobicity? Yes. Is it a problem? That depends. And what I would encourage local soil scientists to do is to identify these soils, and to have them mapped, and to talk with your fuels planners about where your concerns are. And again, as we talked about with the soil heating, if you want to limit the extent of hydrophobicity, consider applying burns that result in uneven forest floor consumption, in mixed severity, and in heterogeneity, kind of the key word for what's going on these days, this forest heterogeneity. And it makes sense here. Okay, here's my favorite topic. Does fire lead to a flush of available nutrients? Of course it does. I mean, there's pictures, there's literature, we hear it from fire ecologists. It does lead to a flush of available nutrients. And the way it happens is that most nutrients, I think as you know, are tied up either in the forest floor organics or within soil organics, or they're absorbed really tightly into soil particles. What fire does is that it kickstarts the nutrient cycling process. And you have two ways to go You either are going to have incomplete combustion where there is mineralization of nutrients. This is the positive. This is what we're looking for. This is the flush. And what happens then is there are particularly nitrogen, but also in the ash, there can be calcium, magnesium, potassium, and others. These are now in plant available form where they weren't previously in tied-in organics. The other side of the sword, though, the downside perhaps, is that with complete combustion by fire, we volatilize nutrients, particularly nitrogen. Okay, it would be wonderful if I could tell you there's a way, there's types of lighting patterns, techniques that you can use to focus mainly on mineralization to increase this and decrease volatilization, but they go hand in hand. And maybe that's a topic we can be working on, but right now they go hand in hand. And the way it goes is the more fuel you consume, and it's primarily a forced floor function, the more you consume, the hotter it gets, the greater the nutrient flush. There's no way around it. If you're burning low to medium severity, and what I'm meaning by severity from a soil scientist, that is the percentage of the forest floor that's consumed, you can see there's a jump in this case, available nitrogen. At high burn severity, you get the most. Now, take a look at these numbers. These are not big numbers. At low and medium severity, I wouldn't call that a flush. Whether a plant is ever going to respond to these low amounts of nitrogen or not is questionable. I would say probably not. So what I tell people is when you burn, prescribed burn at a lower or medium severity, you're not going to find a flush of available nutrients. What about the loss of nutrients? It's the same. It goes hand in hand with mineralization. The hotter the burn, the more forest floor you consume, which we see on the x-axis here, the more nitrogen you lose. Okay. So with low to moderate severity burning, typically values range from 200 to 300 kilograms per hectare loss. That's acceptable because in a lot of cases that can be built up over the years. Now, what happens though if you're burning hot? If you're consuming all your forest floor, what happens if you're out in this range at the 60 megagrams per hectare consumption and you're losing 700 kilograms per hectare of nitrogen? Is that a problem? Right? I mean, how does this really relate to anything? And it is a problem depending on where you are. And again, local expertise here. All right, 700 kilograms per hectare loss, inconsequential or not, it depends. If you're at a productive site like this one here on the left, which is we'll say is well buffered for the amount of nitrogen in the soil, then 700 kilograms, severe burning results in what I would call fairly nominal loss to the total system. If we lose that much, however, in a more non-buffered system, it doesn't have as much total N in it, we're going to lose up to a quarter of the total N in the entire system. So be aware of where you are when you light severe burns, please. And there we go. So does fire lead to a flush? In the case of low to moderate severity burning, no. There is something that's released, but I certainly wouldn't call it a flush. In nutrient-poor forests, and your local soil scientist can define these for you, avoid severe burning and complete duff consumption. And again, uneven forest floor consumption, mixed severity burning, will help reduce fuel loads and reduce the detrimental loss of nutrients. It's a common message here that I'm getting across. All right, pile burning. Is it good or evil? Well, you know, come on, you guys have been doing pile burning for a long time. You know, probably centuries of pile burning going on. Forrest Gump and his mama were burning back in the 50s. So it's something we use. It's not always visually pleasant at times. Right at the time of the burning, it can be kind of fun. But Jack Nicholson says, hey, wait a minute, you know what, you're pushing a lot of heat down into the soil. We saw those graphs, there can be a lot of heat in there. So is it evil? Could be. Or maybe not. You know, maybe most of you are doing these thinning piles that are generally hand piles and small, and maybe it's not a problem. Okay, one way to look at it, and what we've done in our group, is to measure post-burn soil quality right below or within the pile scar. And what we find, you know, you look at this picture here was below actually a wood pile. So you can see a lot of char that's built up. You can see a little, you've got changes in soil, soil color. And when we run a suite of soil measures, we find some things don't change at all and some things change quite a bit. So we do have an effect on the soil. The biology of the soil here compared to unburned soil dropped quite a bit. Physical, we have a great reduction in water infiltration. Okay. So there are some things going on to the soil. It's not a completely bad picture. Not everything is dropping out of sight. And this can be also seen in a paper, a couple of real nice papers by Chuck Rhodes that have just come out. Well, actually, the one on the right is coming out this spring, I hope. It's in press. And their group found similar results in that compared to unburned ground, there is a drop in soil properties and also plant properties with pile burning. In this case, these were small hand piles. I would encourage you to go to this paper. This is a wonderful look at aerial photos and the effects of long-term, the effects of burning. These are clear cuts from up to 50 years ago. So this is the outline of a clear cut. And these dots right here are where they put in pile burns. And so this is a statement that pile scars are still visible up to 50 years after the burning. Okay, pile burning can damage the soil. All right, that's something we must take for granted, but I will say this. So what? The so what comes in acknowledging that there are changes, but then asking yourself the more important question, and that is how much of the ground is covered by piles? If it's 3% and you've smoked the ground a little bit there, within the context of restoring a system, I don't see a problem. I don't see much of a problem at 10% either. It's these areas out here where you get to 20 and 30% cover. If you ever have situations like this, think about what you're doing. So it's the ground cover that matters, not necessarily as much the soil damage. We encourage either the soil scientist or the fuels planner to go out and estimate ground cover. This would be a wonderful piece in a document in a database that people could go back to later when they're looking at cumulative effects. When you put in the pile burn, well, just exactly what did you have? So documentation is a real key in just about everything you do in fuel reduction practices. Okay, so is pile burning problematic? No, it isn't, except when we know with soil heating that when your piles are dominated by large wood, you're going to get a pretty hot pulse, but they also need to occupy a high percentage of the ground. And I believe this is the rare occasion when both of these conditions are met. Okay. What I'd like to do quickly, and please, I hope you're writing questions down. Oh, that's interesting. Are we good here, Josh? I hope we're good. I'm just going to keep going and assuming we're good.
Yeah.
Okay.
Yeah, you're fine.
So we've dealt with some realities and myths. Thank you. We see that there's things to think about, and it's not always cut and dry. And some of the things we thought were true are not always true. That was prescribed fire. Now let's just hit a couple of the topics with thinning that are in the synthesis report. and I want to talk about compaction, and then just really briefly touch the surface of whole tree versus bowl-only removal. How much nutrients to remove from a site. Soil compaction, boy, that's really been, in the last 70 years, since about World War II, it's been the biggest topic of soil scientists. It's been really our big concern. Soil erosion now, of course, is perhaps in the forefront with all these large wildfires, but soil compaction has been such an issue. And there's a good reason for that, and part of it is the visual. Because most things with soils we don't see. But compaction, we see the equipment on the ground, we see the disturbance to the soil, and in some cases we see the changes to the vegetation afterwards. So it's this wonderful visual system. It's not wonderful, it's horrible, right? And what happens with compaction is we know that soils can be easily compacted. It's been shown time and time again. And what happens when you compact a soil is it's a problem, because what you're doing is you're taking the large pores, which are really important for water infiltration, and you're crushing them essentially into smaller pores. So all of a sudden the pore size distribution changes. There's a harder time for water to infiltrate. It can saturate on the surface. It can move down slope, cause erosion. It can lead to problems with gas exchange, obviously root penetration, on and on and on, down to vegetation responses. So we're totally concerned with compaction. And what's happened, the neat thing that's happened over the years, and I believe, and I think you might want to disagree, but I believe this has been a success story. Because practicing soil scientists and foresters have recognized it, and they've recognized ways to deal with it, and we have now a wonderful set of dust management practices to deal with compaction. Number one on the list with compaction is, whenever you can, always, don't even question it. If you have moist soil, if it's leading towards field capacity, keep the equipment off. You will compact the soil whenever you have moist soil. It's just been shown time and time again. The best thing you can do is stay off of moist soil. There are other techniques that soil scientists recommend, and they're quite useful. Whether they're always an option or not, it's hard to tell. Designated skid trails is certainly one that's in favor. The type of equipment, whether you have control over that or not, depends, I suppose, on the contract. There's some indications that if you harvest on top of slash, you're going to reduce compaction, but that hasn't totally been proven yet. Not necessarily the case. And then it's important, of course, for the local experts to identify the high-risk soils, those soils that don't have a lot of rock, that don't have a lot of organic matter. They are perhaps high in silts and clays. These are the types of soils that will compact easiest. We've also come up with, over the years, soil scientists and et al. Have come up with some mitigation techniques. So we're in really good shape, I would say. And we also have now a nice rating system that Debbie Page Demrose and others have come up with, that we can now get into a database to look at trends in compaction. Okay, so a lot of positives, and I'm going to give you just a little bit of data here to back that up, and I don't mean this as a negative thing or as a way for you to go out and go, oh, hey, this guy Busse said there's absolutely no problem, let's just compact like crazy. This is just an observation, and I think we need to be very careful with these types of results. This comes from the long-term soil productivity study, which is a North American, well, it's US and Canada-wide study. Starting in about 1990, we have installed plots, a lot of hard work, a lot of folks in the West Coast, the South, the North, in the US and Canada, to look at what really pushes soils. And are these permanent changes? One of the treatments is compaction, and we have a range of compaction treatments. Is it a permanent effect? Is it consistent across all regions? Does it affect all types of vegetation? So a lot of real basic questions we asked. And here is one plot. This is a plot in California that I've worked at quite a bit. And you can see that it's an artificial treatment. We've come in, and in this case, we drove over the ground with a roller anywhere from 15 to 25 times to compact the ground. The ground was not soaking wet, but you can see it was moist in many places. Okay, so we compacted it. And here's what we found so far. 10 years after these treatments, and there's a paper that came out a few years ago. Looking at the metadata, we found that there was no effect of intermediate or severe compaction on vegetation growth, which is totally dumbfounding. Totally dumbfounding how that could happen. And those of us that have worked on these plots and tried to dig in this soil, it's amazing because it's so hard to break your back to go into there. No effect on the vegetation. 2 months ago, Andy Scott, who is the leader of the national LTSP program, published a paper where he looked at the southern sites, year 15, and first with stand volume. So this is the tree production, if you will. On the x-axis are the 3 compaction treatments: no compaction, moderate, and severe. Look at stand volume. There actually was a slight increase. Not much, but there was a slight increase in stand volume with compaction. Dang. Soil carbon, a good, one of several, but a real good measure of soil quality. Absolutely no change in soil carbon, total soil carbon content in the upper 30 centimeters with these compaction treatments after 15 years. Plant richness, a number of species. So did this compaction perhaps reduce the diversity of plants on his sites in the south? And what he found was a couple things. One, there was, yes, a slight depression in richness, not statistically significant. But also in the south, if you look at the number of species, it was 9 to 10 species. Not a real diverse system that he was dealing with. Overall, though, I think we have a chore in front of us to really understand why this is going on, why we're not seeing what people expect us to find. And he made the comment recently that overwhelmingly the last 2 decades have shown that forest site productivity, and I think what he's getting at is forest soil productivity, is highly resistant and resilient to potentially negative management impact. This is not to say that we don't recommend best management practices, because that's the main point here. But it is to point out that there's some really interesting findings on the horizon. Okay, I'm going to finish up before opening it to questions here real quickly. We got a lot of questions about whole tree harvesting. So when you remove the whole tree instead of just the bole, you're taking up a good percentage of the nutrients in the crown and taking it off site. Is that a problem? Are we reducing the fertility of the site by thinning and removing the whole tree? There have been studies, particularly in Scandinavian countries. It's inconclusive, but there have been some studies showing that indeed on very, very infertile sites that if you do a whole tree removal, you're going to run into a problem. When we look at, so the bad side of whole tree harvesting is nutrient removal, but there's a positive too for whole tree harvesting. And again, this is all about balancing the system, right? The positive is that you're removing some of that fire hazard, reducing fire hazard. And if we're talking about biomass removal, there may be 10 to 15% of the biomass that you're removing with the crown. So pluses and minuses. What we're finding, again, this is kind of busy, but what we're finding is that the amount of nutrient, in this case nitrogen, that you lose by whole tree harvesting is not that much. It's not a big deal, regardless of the system you're in. In a well-buffered system, bigger crowns, again, it depends on how much volume you remove and a lot of individual site factors. But in this exercise, we lost 2% of the total nitrogen in the system. Big deal. In a more nutrient-limited system, smaller crowns, still it's only 5% loss. So by and large, what you find with whole tree harvesting, you're not running into problems with a soil or a site fertility issue. Okay, I hope some of this has piqued your interest and that you have some comments and some concerns, and that's been of some value to you. The take-home message, I think that what you've seen is that for the most part, except for some caveats, don't worry, be happy. When you're dealing with fuel reduction practices, we're in pretty good shape. Right? With what's being used today, we're in good shape. The main caveat, it will be the cumulative effects. And we need to get a better understanding of that. Soil, another bottom line message is soil is a piece of the puzzle. It's not the puzzle, but we need to embrace it. There's ways to balance fuel reduction and maintaining soil health that are not that challenging. That's the real positive side to this story. Please embrace local knowledge of soils. And when you have new folks come on board, new soil scientists on your forest or your district, help them. Bring them out to the sites you're concerned with. Talk about the issues. That's what we need, is that communication level. Identify what the challenges are. Are they low fertility soils or perhaps riparian soils? You name it. From the document, we did find some very basic principles in literature. Most burns don't damage the soil. If you're concerned about that, burn it when it's moist. Ask yourself, is hydrophobicity a problem where you are? Okay, on and on and on. Nutrient content, the nutrient flush was not really a big deal. Best management practices for soil compaction and then whole tree harvesting does not appear to be an issue. So what I'm going to do is I will turn, I think, Josh, what we do is I turn this back over to you for the question and comment period. But I do want to point out, for those of you interested in this publication, here's the information. The easiest way to get it is just to Google PSW GTR 241. You'll come up with it. Or if you want, send me an email and I can send you a hard copy. And again, I really appreciate your time. I appreciate your interest in soils and maintaining the integrity of our forest systems. Josh, are you there?
Yeah, I'm here, Matt. Yeah, thanks a bunch. That was a great presentation. That was really engaging, clear, and using Forrest Gump and The Shining on one slide. That gets all the awards in my book, actually.
All right.
A great job. But here, I'll go ahead and move to the questions. We got quite a few, so I'll start working through them. The first one is from Gabriel Bissonette, and this came early on, so I'm not quite sure what he is referring to, but he says, what is the name of the resource mentioned? You know what he might be referring to there?
Oh, Gabriel, that's probably the GTR that we're talking about. So here's the information to get that.
Okay. Kayana Warren asks, these are great graphs. This is also early on. I think I remember which ones. It was one of the first few slides. Do they change much with different kinds of soils and different conditions?
Boy, without knowing, those are probably the soil heating ones.
I think so.
I'm going to go with that. Since I can't talk directly with the questioner. You know what? We've looked at that. And does soil texture matter, for example, which you would think? The amount of clay or sand in your soil. And what we find is no, that's not a real driving force of soil heating. The two drivers are fuels and the way they're burned, and then soil moisture. Soil moisture way far is the biggest soil issue beyond texture or organic matter content.
Okay, Pauline.
Send me an email. I can give you a follow-up publication on that.
Okay. Pauline Adams asks, can you better define what constitutes moist soils and what is the best way / equipment to test this in the field prior to a burn window?
Yeah, I think I used the term moist when we were talking about compaction, and to be honest, I'm not really pleased with the literature on what that point is. Most people say that when you're at field capacity, that's definitely when you want to avoid having equipment on. Field compaction being roughly 24 hours after a rain. So all the soil pores are filled except those gravitational pores where the water has moved through. So below there, it's going to depend on the local expertise and the knowledge of the soils. Is it a clay soil that may compact easier than a sandy soil? Wish I could tell you, yeah, 30% in this type of soil. That's when you stay off of it. I can't give you that information. For the soil heating, what we've found is when you're above 20% moisture by volume, it's very hard to push the heat profile into the soil. So that I'm comfortable with saying about 20% by volume. That's a real nice threshold for soil moisture and heating.
Okay. Eric Nisita asks, does drought increase hydrophobicity and make it more persistent post-fire?
Yeah, thank you, Eric. Absolutely. There's been a lot of work on that. What happens, hydrophobicity increases as the soil dries. So if you have a burn and you come out the next spring and summer, as that soil dries, it's getting more and more hydrophobic. The concern with that is if you have a fairly large storm first thing in the fall, that's when you're going to have the most hydrophobic, most repellent soil, and you're going to have movement of the soil off the site. If you're getting gradual storms that can wet that soil up, then you're in good shape. So once you wet up a hydrophobic soil, it is no longer hydrophobic. Once it reaches that point of being saturated, being wet again, it loses that. So the real key, Eric, is what's the nature of the storm after the drying period, when the soils, like you say, become more hydrophobic.
Okay. This is sort of a related question, good follow-up for that one. It's from Derek Milner, and he asks, are you aware of any good gross indicators of natural soil hydrophobicity potential, for example, vegetation community, soil texture, climate, etc., to screen planned burn polygons, or will we need to assess each unit individually prior to implementation?
I'm not aware of it, but I'm shocked that there isn't. And this really is Ken Hubbard's expertise, and I can get back to you on this question because I know there are certain plant community types. We think of chaparral systems with plants that have a lot of waxy leaves that tend to be hydrophobic. But as far as forested systems, I don't have that information, and I certainly hope that those of you that do can share it with us. Yeah, that's what we need. We need this on a layer. I'd hate to have people that go out to every site before a burn and say, well, we're really concerned. There's not enough time to do that. So we really need to put that together. And I'm afraid I don't know who has done that or not. It needs to happen.
Okay.
Perhaps, Derek, you'd like to get going on that.
Okay. Next question for Bill Elliott. He asks, any thoughts on the impacts of management on soil phosphorus?
Soil phosphorus is it's really perhaps the most complicated of all soil nutrients and how it responds. Management impacts that we've talked about here today, I don't see a whole lot of impact because we're looking at soil temperatures that don't get up to that range, and the 500 to 600 degrees centigrade where you release a lot of phosphorus, volatilized phosphorus, so we're not going to see that. You may see movement of phosphorus after a fire, but it's hit or miss. So I hate to say that there's going to be a whole lot of impact of these types of management on phosphorus. But then again, there's a lot of caveats to soil phosphorus that makes it so complicated. to practitioners at this point in time, I would say that's something that you probably don't need to be focused on until we come and tell you specifics.
Okay, next question, Dale Stewart. When you describe pile burning, it appears that the amount of soil incorporated is nil. That seems different from past practices of piling with a brush blade. Is that correct? No soil incorporation is the key?
Yeah, good. Thank you for saying that, Dale. Absolutely. I mean, the old practices of piles put, they could, not necessarily, but they would also incorporate a lot of soil into the pile. And what that did was it trapped the heat, and the heat went down, and you had more soil heating, more damage. So now we are here in the feel-good era of forestry, and we don't do that. Or we have hand piles where there's really no chance of incorporating soil. Most of what I talked about were dealt with hand piles. So the damage is pretty limited when you don't have that soil cap. So that's a really wonderful point. Thank you.
Dale asked another question. It's sort of related to one above, so if you've already answered this, let me know. But he asked, what level of soil moisture would you consider to be moist? 20% or 25% or more?
If you do it by volume, you see soil moisture. The benefits of soil moisture and soil heating depend on soil texture. There's 20% moisture in a sand is different than 20% in a clay, right? But what we found is across textures, if you are 20% by volume, then you're in good shape across all soil types.
Okay.
Anything above that is even better.
Okay. Next one's from Joe Sherlock. Would you review mastication effects again? What would you think about a young forest that has had an associated dense manzanita masticated?
Okay, thanks, Joe. Yeah, one of the points we make in our publication is the jury is still out on what its effects on soils are. So I can't give you a black and white story. However, what people have seen in literature and what our experience has been out in the woods is mastication does not have a huge effect on soils. It's going to alter soil temperature and soil moisture, yes. But as far as other processes, it's not that big of a deal. The burning part, you need some talented burners, I believe, and there's a lot of talented burners out there. And what we've seen is the issue is more with, are you burning up trees, not are you pushing a lot of heat into the soil. So most of the heat with masticated fuels is going up. I would add with dense manzanita fields or understory of dense manzanita, what I see, because if you think about a manzanita brush, there's a lot of air within that shrub, and so when you masticate it, you don't get that thick a layer of masticated fuel. And I've yet to see any problems with soils associated with brushes being masticated. We look at changes in nutrients, in soil biology, in amount of CO2 release, and we don't see a big effect. What will happen when you also include in your masticating process the thinning of small diameter trees where you can actually get a lot of material? That's another story. But with shrubs, I don't see it being an issue, Joe.
Okay, another question from Dale Stewart. Weren't the LTSP study sites mostly those with high sand content where compaction sort of helps that effect?
Dale, you should have been giving this webinar. Very good. Not necessarily. What the LTSP sites had in common is that they were all on well-drained soils, or reasonably well-drained soils. So we didn't look at compaction on some of these more fragile systems, which that's just the way it was. But there was a range of textures. The early results from the LTSP indicated that when you compacted a soil that was sandy, you had actually increase in tree growth and vegetation growth because you increased the water holding capacity of the soil. And that was a really nice finding. But what we're seeing now in the literature is that it's going across textures. It's not just the sands. Okay, that's the dumbfounding part. When we thought it was just the sandy soils, we went, okay, get it. But now we're kind of back to the drawing board as to why this is happening.
Okay. Next question from Steve Popovich. Any data on pile burning impacts to seed banks? Also, does Rhodes touch on increase in weeds and pile scars?
Yeah, Steve, go to the papers by Chuck Rhodes' group, and there's a few others in literature that do look at the seed bank. I think the latest one, which isn't out yet, but you could probably contact Chuck and you can get that information, does look at the impact of the seed bank, where there has been an impact, but it's fairly short term. And also he does get to the issue of invasives and weeds. It's hit or miss. You know, what I see in literature, where you have weeds present to begin with, there tends to be an increase in weeds. But it's not like this huge day and night, like, oh my God, look what we've done to the weed population. So it's more a shade of gray that, you know, yes, some concern, but the other thing is to be aware of this, of the site and the system.
Okay.
Steve, I'll send you a link to the papers.
Next question is from Kathy Miner. During the large wildfires we had this past summer, emergency fire lines were created to save the rural communities. The piles are 20 foot plus high, 20 feet plus high, and about 25 feet plus in diameter. They are made up of from 4 inches to 20 plus inches diameter debris. Should we try to break up these huge piles into smaller piles before burning?
That's a wonderful question, because you get at all of the issues. It's not just soil. I mean, it's an emergency situation. You know, you've created this thing. You're dealing with a wildfire. You're dealing with post-wildfire conditions. You know, in a perfect world, the answer is yes. Please do that. But it's not a perfect world, right? So you will. If you have a lot of these piles and they're all 20 to 25 foot in diameter and all made up of big wood, yeah, if you can split them up some, that would be great. But I don't think I'd put that high on my priority list. My priority would be recognizing and documenting what you've done and seeing after this whether there's any potential rehab to those burn scars. That's a topic I didn't discuss, is that people do look into rehabbing the burn scars by either adding a surface mulch or incorporating a mulch. You know, there's ways to deal with it that are also beneficial. So a good conceptual.
Okay. Next one's from Kayana Warren. I noticed very few experimental sites in particularly dry areas for Southern California, for example. How much of these take-home messages apply to these areas?
Well, yeah, that's a good question. I would, you know, as far as the compaction, the LTSP study, some of the principles, you're going to have to translate, you yourself translate the principles of how the system works to your own types of vegetation communities, whether it's forested or chaparral. I would say that with the burning, it does translate. The soil heating definitely translates into Southern California. You probably, if anything, you're going to have fewer impacts on the soil where you have the chaparral or perhaps grassland type fires that are fast moving, less fuels than some of these forest fuel reduction practices. So, you know, it's a weak answer. You know, it doesn't translate perfectly, but I think you can use the information and figure out what fits and what doesn't fit.
Okay. Johnny Boggs asks, that nitrogen soil loss by whole tree harvesting is over what period of time? Perhaps a cumulative 5% loss will be a problem over time?
Yeah, yeah, I didn't make that clear. That is a one point in time. That is a one-time thinning harvest. So perhaps it will, and that's exactly the point that I want to make here, is the cumulative effect. Are you going to come back in and thin again? Are you going to remove more? Are you going to come back in and masticate, or are you going to come back in and burn? Are you going to burn on a 5-year, 10-year, 20-year cycle? Each of these processes are going to result in, a bigger loss of nitrogen, a cumulative loss. But then we also have to throw in the other side of the equation. What's being added to the system? Are there nitrogen-fixing plants? Are there CNF species that are adding into the system? What about atmospheric deposition? So there are takeaways in this cumulative effects. There's also gains over time. And here I think I really want to push the idea of, as much as people can, putting together these types of treatments into some type of spreadsheet where folks in the future know what's happened. It doesn't have to be incredibly quantitative, but a qualitative spreadsheet of what's happened, what you generally think you might have lost with a harvest. That's the real strength. I think that's how we can move forward and be on top of the game here, is just documenting everything.
Okay.
I apologize. I can't. This isn't interactive, so I can't. I want to be able to hear from you guys. Wait a minute, that's garbage. Or, oh yeah, okay.
Okay. There's still a lot of questions. People are sticking around, so I'll keep going as long as you're willing to keep answering questions. But there's quite a list. That last question actually leads into this next one. It's from Dale Stewart again. He's asked, what would you recommend for those that do not have local soil expertise on the forest or districts when it comes to pointing to the problem areas?
Higher local expertise. I'm sorry. Yeah, this is a real issue, and there are areas where you don't have the local expertise. I mean, there's got to be access at one way or another. Either as a forest soil scientist, a regional soil scientist, a zone soil scientist. Get on the phone, talk to people. I would get on the phone and talk to university soil scientists, extension folks. People are out there. They're not always right at hand. And we in the soil science world, it's depressing, because you see a lot of positions that were once filled are now not being filled, and where we need it to happen, and we don't have much of a voice in that. So the best you can do is really try to connect. We have the internet, we have email. You can send anyone questions, and people are usually happy to respond.
Okay. Next question is from Bob Easel. What is the effect of nitrogen fixation by Cyanthus? Sorry, I might have screwed that up. Cyanthus following stand replacement fires.
Yeah. Cyanthus is a nitrogen-fixing shrub. There's many species of Cyanthus, and it's a wonderful effect. We've measured rates of N-fix by Cyanthus over the years, and it does vary by species, but it's certainly a way to bring back nitrogen into the system that's lost during a stand replacement fire. What I've measured in forest systems, it's not like an agricultural system where you have a field of alfalfa and you're going to expect a couple hundred pounds of N per acre per year added to it. It's more in the ballpark of 20 pounds per acre per year. But over a 10-year period, you're replacing that N. So there's the trade-off that happens here, and that is, if you know you've lost a lot of N in a fire, encouraging nitrogen-fixing plants is a good thing. But at what point in time do those plants then become the future fire risk, or fire hazard, if you will? So that's a wonderful issue to try to deal with.
Okay. I'm going to skip a few that are similar to previously asked questions. So if you're out there and you're wondering why your question was asked, I'm sorry about that, but we have a lot, but there are a few I'm skipping. Ryan Good asks, do you have a soil rating scale for landscape level risk for soils?
Yeah. Ryan, boy, I wish I had the publication right at hand, but if you track down, if you go to our publication, the one that I had on the screen, in the references there is, I'm looking at it right now. The reference is start with Paige Dumrose. So you'll find several references to her work in our literature cited, and in this, she'll go through the risk rating system, and I think it's a nice one. It's pretty simplistic, and also there'll be a link to the national database. Good. I'm glad you're looking into that.
Okay.
Wait a minute. Do you have it for landscape? Well, it's as landscape as possible.
Okay. A couple questions here about the size of piles. For limiting soil damage, would it be better to have more but smaller burn/piles or fewer larger piles?
Yeah, that's a question we get a lot, and what we found is it doesn't matter. It doesn't matter because you're either going to have a little more soil, if you have bigger piles, you're going to have a little more soil damage, but the amount of ground covered isn't necessarily, it's actually less than if you have smaller piles but more of them. So it's a push. And in the long run, we tell folks that don't focus so much on the size, but focus on how much of the ground is being covered. Small, many, or larger, fewer, not a big deal.
Okay, Dennis Halema asks, do you favor the usage of the term natural background repellency? Dora et al., 2009.
Yeah, absolutely. Dor, oh, Dennis, yeah, of course. Dor is probably the leading expert in the world on water repellency, soil hydrophobicity, if you will. The natural background, what the site has to begin with, absolutely. That was one of the main points I was trying to make, is with or without fire, there is a natural background. Fire happens to strengthen the background, or not the background, how much repellency you have, but there is a natural background. And again, in our publication, we do cite Stefan Dor's work, and you'll have links to that.
Okay. Next question from Robert Davidson. When discussing long-term effects on soils following burning, did you consider the loss of soil, including seed loss, on steep slopes from hydrophobicity impacts, thus long-term loss of soil productivity?
It's a big part of the equation, and that comes down to the local issues. We didn't do a real good job of including slope into this, but obviously on steeper slopes, there's going to be a greater risk of erosion, of course, and that hydrophobicity will play a bigger role. Even if it's spatial, even if there's a lot of variability, that increase in the amount of energy moving down slope is just going to be much more severe. So yeah, that's a real good point. Be extremely careful, and that's the type of situation where, the local talent will go, hey, you know what? If you burn, we're seeing more hydrophobicity. We really want you to back off on these steep slopes.
Okay, next question from Ward Fung. We're starting again with broadcast burns, and to minimize duff consumption and potential soil erosion on sensitive sites, we do recommend cooler spring burn conditions when the soils are moist. One complication is that people are concerned that the cooler burns allow more invasive plant species versus conducting a hotter fall burn when soils are drier. What do we do?
I think, first of all, you have to prove that. There's a couple things. You have to prove that indeed there are more invasive plant species with the cooler burn. So, your botanist or your plant ecologist needs to get out there and really, to me, they need to prove it, because what I don't always see that on the burns I've worked on. I don't see this huge change in invasive plants. I'm not saying it doesn't happen. Of course, it can, and it probably does happen in a lot of cases. But identify those situations. it's a big issue. The other thing that you have to deal with, whether you're going to burn in fall or spring, is when do you have the window? I mean, this is all part of that. Uh, we're all trying to work together, right? So there's soil issues, there are invasive issues, there's fuel issues, when you can get it done. So, boy, you've got to take it all into consideration. You can't just focus on one thing or the other. I guess that's one of my take-home messages today. And this question really gets at that.
Okay. Couple more maybe. We probably should.
Let me just add, Josh, that a lot of, especially fire ecologists, want to push the burns into the timing of the fall, maybe even towards late summer when fires actually were occurring historically, and that's totally a valid point, and it gets at this question because that's how plants are responding, and that's how they responded over time. Burning when they were not actively growing would be a good thing. So it is something people want to do. Whether you get the window in the fall to get it all done or not is the other question.
Okay. Sherry Howell asks, we've used depth of ash / burn layer in the soil to help determine soil damage. Is this a good indicator?
It's not a good indicator of soil damage. It's an indicator of how much material you've consumed. So it doesn't necessarily mean, if you believe that the hotter the burn, the more damage you have. If that's a direct connection, then yeah, because you've consumed more material. And you've got to really, Sherry, define what you mean by soil damage. If you're just speaking about a nutrient like nitrogen, yes. Okay, the more ash, the more you've probably lost of that nutrient. But if you're talking about other things like soil structure or water movement or infiltration, it's definitely, I would say the jury is out on depth of ash. It's just an indicator of how much material was consumed. So I would be hesitant about that. Really define what you're talking about.
Okay.
And again, define it within a stand or a landscape. How much are we talking about has that ash layer on
it? Okay. Sean McElderry asks, what's your opinion of applications or models like FOFM for use in planning prescribed fire?
Yeah, FOFM's a nice model. It's the first order fire effects model. I think that's what it stands for. So it looks at first order effects, and with soil, what you get out of there's actually a routine for coming up with a soil heat profile. So the pulse of heat into the soil depending on the conditions of the burn. The vegetation, the fuel loads, fire, wind, speed, all these things, and you can come up with how much heating is going on into the soil. My opinion about that component of FOFM is that it is very weak. And it'll give you an indication, but it's very insensitive to changes in the system. And it's based on a model, physical model that really wasn't tested out in real life. And so when I plug my conditions for underburns or for pile burns or for masticated fuels into FOFM, and I look at the heat profiles, they don't even come close to what we see in reality. So I would just say, be careful. There really isn't anything better if you're looking for a quick model of soil heating, but be careful with what you gain from it. That's a good question.
Okay. Are you still okay, Matt, or should we take a break? There's a lot of questions here.
Why don't we do a couple more?
Okay. And then maybe we can.
I'm old. I can take a nap. Come on.
What I can do is I can forward.
I'm sorry. No. Yeah. Whatever you want to do.
Well, we'll do a couple more, and I can forward the remaining ones onto you, and you could maybe reply to them.
Oh,
gets email contact.
that'd be great.
Okay, so let's see.
I really appreciate all these questions.
Sure. Um, Here we'll get down to someone who hasn't asked yet. Eric Robertson, I know Eric. Have you considered establishing an LTSP site in any forests of the Southwest? It'd be interesting to see comparison results of soil fertility slash long-term site productivity studies you guys do on other sites versus the highly moisture limited forest types down here.
Yeah. No, that's a great question, and this LTSP study, I mean, the answer is no, and I don't think it's going to happen at the scale of the entire network because it is so much effort. Folks that put those sites in initially, I mean, holy mackerel, it just amazes me what they went through. So it's a huge effort. It's not something you can take lightly. On the other hand, there are folks in the Southwest that have been looking at this type of work. And there's other studies, the folks I would recommend, Eric, you getting a hold of course, is Steve Hart, Steve Overby, two of the top folks that I think of to talk to that have done a lot of work in the Southwest. Boy, it'd be great. And this is another point about long-term studies. This program got a lot of funding support when it got going. So that's how the study got in. And there's other studies like the fire surrogate study that had a lot of funding support to begin with. You get funding for 5 or 10 years. And then there's this collective memory loss by those folks that have the money purses. And so you all of a sudden you're struggling to get money. So that's where the LTSP project network is right now. So we'd love to put in more, but it's not going to happen. So there's a missing piece there for the Southwest.
Okay. Well, I think we'll cut it off there, and what I'll do is I'll pass these questions on to Matt, and you guys can get in, or you can contact him directly through his email there. And
okay, Josh, can I just say one last thing? I see this one comment from Chuck Rhodes, who pointed out that the paper dealing with soil and plant responses to pile burning, that paper is out online. So I'm guessing you can Google that. I should know what journal it is. Is it Soil Science Society of America Journal, Chuck? Anyway, Google either Chuck Rhodes or pile burning, and that paper hopefully you'll hit a link to that. So his paper is out. So thanks, and Josh, thanks for your efforts today.
and thank you, Matt. That was a very, very engaging presentation and a marathon job of answering questions there. That was very good. And thank you to the audience. If you a few people wrote in asking about the recording, and I have to convert the recording and do a little editing and upload it. It usually takes an hour or two, and they'll be available on Advances in Fire Practice shortly, so you can get that link and pass it on to anybody you think might be interested. And thanks everyone for coming, and thanks, Matt.
Welcome. Thank you, everyone.